Hello, in this video I will show modifying the flight tracker application I've been developing with AI to use a live data source for the aircraft it displays. The data source used will be OpenSky network. To provide the bottom line up front, for this change I think using Codex provides a roughly 4x improvement over a human doing the change independently. I was using GPT-5 Codex at the time this change was made. It was before GPT 5.1, or 5.2 obviously, was released. Before this change, tracks were injected into the system via a simulation system written by Codex for the flight tracker application. This simulation system works well enough, but I wanted to see live tracks. OpenSky Network provides a free live ADS-B Mode S feed via a few APIs, one of which is a REST API, and this is what the flight tracker application uses. On the screen you can see the type of data returned from OpenSky's API. The request is made for all the aircraft in a geographic area defined in the request. The JSON formatted response contains a timestamp and then an array of aircraft. On the left of the screen is the prompt I supply to Codex. I start off by defining the top level objective, using OpenSky Network's API to source real-world live aircraft data. Next, I specify that the application will now need to be run in one of two modes, depending on the desired data source, the existing simulation system or OpenSky's API. I then specify the rate to poll OpenSky's API. Perhaps I didn't need to do this and I could have let Codex figure out the best approach. The next requirement I specify is that the application should always define a geographic area we are interested in. Lastly, I tell Codex to only make a plan at this stage and to ask any clarifying questions it needs to. In about 30 seconds, Codex has devised a plan. It is quite long and includes several questions for me to answer. The plan has some good ideas that I did not ask for, such as displaying which mode is active, being able to specify multiple geographic regions in a JSON configuration file, handling missing fields in the OpenSky data gracefully, filtering out data that doesn't have essential information, logging OpenSky parsing issues with a backoff to avoid log spam, changing the track coasting rules when in OpenSky mode due to the slower update rates compared to the simulation system, retry backoff with circuit breaker to handle the API going down, and updating the readmes on how to use the new mode. After providing the clarifications that Codex asked for, which aren't particularly noteworthy, Codex reformulates the plan in about 20 seconds. The updated plan is, once again, lengthy. I add one last noteworthy refinement, which is to display the time of the last OpenSky response, including a subtle indication to the user every time this is updated. I then ask Codex to implement the plan. Codex took about 12 minutes to implement the plan, adding 694 lines and removing 9 lines across 11 files. In other words, Codex modified roughly 1 line per second. After following the instructions to start up the backend in OpenSky mode and the web client as normal, the implementation looked correct first go. This larger change being implemented so quickly with no bugs would be impossible for a human. I was quite impressed by this. After some very quick quality assurance, I tell Codex I want to commit the change in Git and ask for a Git tag up revisioning approach. It suggests what I would have done myself, so I ask it to commit the change. All up, I spent about 35 minutes of my time working on this new feature. This included writing the prompts, reviewing Codex's plans and answering questions, and doing some quick quality assurance. Some of this 35 minutes was waiting for Codex to complete a request. I could have been multitasking during the time Codex was working. There is no way a human of any experience level would be able to make this change in 35 minutes. It would be more like a full day's work or perhaps half a day for an experienced developer. Assuming 6 hours work for a human to do this, that is over a 10x productivity improvement. The change is too big to review in this video, but it did look satisfactory to me when I reviewed it. Over time, a developer may learn to trust the AI and may choose to forego the review entirely. Some fields or industries will never forego a human review. Assuming 30 minutes to review the change, this is still a 5x improvement over the human doing this change. Allowing 60 minutes to do a more thorough review of the change, this is a 3.7x improvement over a human doing this change independently. I found asking Codex questions about the implementation useful while doing the review. One thing I have noticed when reviewing Codex's change is that it does not comment its code much or at all. I am sure this is easily addressed by specifying this as a requirement in the prompts, but it is something to be aware of. So, in summary, depending on how much you wish to review the change, I estimate that working with Codex can make this change 4 to 10 times faster than a human developer doing the change independently. Before I close out this video, I just want to give a quick demonstration of the application as it stands right now. So what you're looking at is about 21 hours worth of work on my part. So I've been working with Codex for about 21 hours, roughly 3 days, to produce the flight tracker application. So we're looking at the OpenSky integration here now. So it's grabbing live data from the OpenSky network. You can see, just I might point out some highlights. Up on the left-hand side, top left up here, you can see that little green indication there. That's the indication that a new OpenSky data packet, or we've received some live data from OpenSky. So all I did was tell Codex, I just want a subtle indication to the user that a new OpenSky data has been received, and that's what I come up with. Like I didn't give it much much in the way of direction beyond that. So it did a pretty good job there. You can see up here it's connected. So this is telling us it's connected to a network or OpenSky or the simulation system. It's a bit hard to read here, but it is telling us what area it's receiving data for, and it's polling every 5 seconds. Yeah, it might be a bit hard to read on YouTube. So down on the bottom right here, you can see we've got the total tracks in the system. So there's 39 aircraft currently in the geographic area that we've specified we're interested in. We can see all 38 at the moment. So let's zoom in, and you should see this. The total tracks will stay 38, of course, but we should see the visible on the map reduce as I get closer and closer. So here I am, I'm zoomed in close to, this is Brisbane Airport here. So we're down to 11 now. So let's select another track, and it changes. And you can see I've also got the rollover working as well. I told Codex figured that out itself. So this is some extra track details. When you select the track, it highlights it, and you get some extra details about the track here. This is all live, real data too, by the way. And you can faintly see there's a small history, although that's not working perfectly because it's got some yellow in front of the track at the moment. So it's something I'll have to fix up. We'll get Codex to fix up. Yeah, so let's try searching on a track. So maybe, well, this is Brisbane Airport, so these guys should all be on the ground. So let's have a look at JST 801. Let's just do a search for JST. So it's, I just did a search for JST, so there's a bunch of Jetstar aircraft, I'm assuming. So we're interested in 801, so let's select that. You can see it's selected over here. The details have changed. Altitude 0 feet. That's good because it's on the ground at the airport. Yes, let's just get rid of these other guys. Actually, what I will do is select the one in the air. And let's fly to it. So center on track. So we can see, it's what we were looking at before, or one of the ones, I think it was. We can follow it. So now the map will move as this track is updated every 5 seconds or so. So there it goes. We can turn that off as well. Yeah, so like I was saying, that's about 21 hours worth of work, which is, it's pretty impressive to me. I don't think I would have done that myself in 21 hours coding manually. So yeah, that's where we are now with the OpenSky integration complete. I'll be moving on to my next feature development. I'm going to try and do is some live AIS data, so that ships, so then I'll be able to start seeing ships being tracked as well. Pretty sure I'll be able to find a free live stream for that. And there's some other improvements I want to do. Obviously the symbology I'm using here is not particularly great, but I actually told Codex to do that. I was very specific about what I wanted, and I'm going to change that to match what you see in one of your Flight Radar 24 top applications. And I'm also going to start. So all the work so far was done back in early November, and I've just got around to finishing the videos now. And so that was Codex. GPT-5 and GPT-5.2 is out, so the next developments that we're doing, we're using GPT-5.2. That'll be very interesting to see how that goes. I was pretty impressed with GPT-5, so it should be better, so hopefully I'll see some observable improvements there. And I'm also going to try experimenting with another AI as well. I'm going to use Claude. I'll get Claude installed, and then the feature developments I'll probably do will be, I'll do the same feature development, but I'll get GPT 5.2 and I'll get Claude Code to do the same. I'll give it the same prompts and compare and contrast, and I might even experiment with using one AI to review the code of another AI. There should be some more videos coming in a not too distant future. Yeah, that's it from this one. So I probably won't make another video this year. So yeah, have a good Christmas and a good New Year, and I'll see you in the next video.